this video is going to be a little choppy because I forgot to record the start of the lesson. So I've taught the lesson, I recorded most of the lesson, so I'm going to go back and redo the first part of the lesson for you guys. So first thing, we're doing exponential growth and decay. So first thing I want you to do here is on your notes to self, write down these basic parts, okay? Right here, so you can pause the video and write down these basic parts along those lines right here. So the big thing here is the number to the left is your final amount. Your initial amount is your A value. Your rate of growth or decay is your B value here. And then the number of growth periods is your X value. Okay, so pause it, write those down in your notes to self, which should go right here. Okay, kind of gives you a guideline of what all those numbers mean. Now we're going to look at growth first. Okay, so exponential growth. So the meanings are still the same. We just took that B value and made it a little bit bigger, right? And we gave more purpose. So A is still our initial amount. R is our rate of increase, and T is time, as in how many growth periods we have. Okay, so write that in your notes to self. This will go under your exponential growth section here. So write down that formula, and then we're going to do a couple of little questions that go along with it. So pause it here. And go from there. So let's keep this up here. So we're going to do a couple little numbers here just to remember how to do growth. So let's say my growth rate is 15% growth. Okay, that's the worst growth ever I've written. Okay, so this is my R value. So my R is 15%. But we don't want it as a percent. We want it as a number. So we're going to do that 15% to make it into a number is divide it by 100, which equals 0.15. Therefore, if I took these brackets, if I just took the brackets part of here, this would be 1 plus 0.15, which would equal 1.15. Okay, that would be the inside bracket part there. So let's do another one. Let's say it's 8% growth rate. Okay, so I want you to pause the video here and see if you can make that 8% into a number and then put it into the brackets like I did over here. Okay. So if I want to do this, I'm going to take my 8%, I'm going to turn it into a number, so I'm going to divide it by 100, which equals 0.08. I'm going to go to my bracket and go 1 plus 0.08. 1.08 is going to be my number inside that bracket. Okay? We're going to practice a couple of these. The big thing here is you know that growth, if inside that bracket is bigger than 1, you know it's growth. You know it's decay if it is less than 1. And we'll do decay after. Okay? But just know growth, the number inside that bracket is bigger than 1. And we're talking about this bracket here. Decay is when that number is less than 1. Let's do a question here. So, first thing we're going to do is create a little formula here. So let's write down our original formula. Let's talk about bacteria. So total bacteria is A bracket 1 plus R to the power of T. So let's write down our things here, R and T. Okay. So in this question here, they don't give us a T. So there's 5,000 cells in a bacteria culture. The number of cells grow at a rate of 25% per day. Determine the equation. Now they don't give us a T here, so we're just going to leave T as blank right now. That's fine. What's our original amount of bacteria? Well, the original amount of bacteria is 5,000. Okay. And what's our growth rate? What's the growth rate of our bacteria? Well, it's 25%. Now remember, we don't want that as a percent. So we need to make it into a number, so we divide it by 100. So that's equals 0.25. So then let's plug it into our equation. So bacteria equals 5,000 bracket 1 plus 0.25 the power T. 5,000 1.25 to the power T. So there's our equation that there's our equation of bacteria growth. Okay? And then we can go down here. Oh, and copy that piece down. Fine. So the question is, I'll write the question over here. How many bacteria will we have after 1 week? Okay. So how many bacteria will we have after 1 week? So we need to figure out our T value. What's our T value here? That's the only thing we're missing here. Well, T, if we remember way up here, it was a per day number. Okay, so 1 week has 7 days. One second here, I'm answering a question in chat. So 1 week is 7 days. So therefore our T value is going to be 7. Then we can go back in here and we plug in the T, we replace this T with an exponent 7. Now if I use my calculator, it's going to be 5,000 bracket 1.25 bracket, and we're going to go to the power of 7, so it's going to be the power of 7. Good. And that's going to be your answer, 23,842. Perfect. And then I'm going to link you back with the previous lesson that I recorded right now. All right, let me wait for it to start recording. All right, it's recording now. You're right. So the 5,000 is my original amount of bacteria. So that is going to go right here. Who can tell me what my R value is? What's my R? What's my rate of increase? What's my rate of increase in this question? There are 5,000 bacteria in the culture cell. The number of cells grows at a rate of 25% per day. Good. So that's 25%. But we don't want it as a percent, right? So we're going to divide this by 100, which is going to equal 0.25. Okay? Now, in this case right now, we don't know what our T value is, or BT. So let's just write the original equation. The original equation is bacteria by time equals 5,000, 1 plus 0.25 to the power of T. And if I reduce this, there's my equation for growth of bacteria. Okay? How do we feel about that? Does everyone understand how I got from here to here? Yes, no, maybe so? Okay, Farley says yes. Gabe says yes. All right. So we're going to do a couple of these questions, so don't worry about that. So I'm going to write my equation down here. All right. So how many cells will be there in 1 week? So what's my T going to be now? For 1 week in time, right? What's my T value going to be? 5,000 cells of bacteria culture grow at a rate of per day. So what's my T value going to be if I'm waiting if I want to know how many cells, how many bacteria cells will be there after 1 week? Kovat says 7. Dominic estimates 175. Right, there are 7 days in a week. Right, so our T is going to be 7. So if you look at here, our bacteria level at 7 days equals 5,000, 1.25 to the power of 7. If we do that on our calculator, and I'll do it on both calculators. For this one here, I go 5,000, bracket, 1.25, close my bracket, hit my exponent button and press 7. Therefore, I have 23,000, oh, where'd it go? 842 bacteria. Now, I'll also do it on this calculator, since I know some of you have this. 1 second, where's my thing? So, this one, what I would personally do is I go 1.25, hit this power button here, 7, press equals, and then times it by 5,000. Okay? Does everyone understand how to plug it into their calculator or phone Or do you need another example of it? Okay, which one, Dominic? The calculator or the phone calculator? The iPhone or the calculator? The phone one? Okay. So let me clear this again. So when I use the phone, I'm going to do this part first. 1.25. So 1.25 to the power, which is this y to the x button. Y to the x. So 1.25 to the power of 7. So I'm going to press equals. So right now I've done this part of the equation. Then, so now I have to multiply this by 5,000. So I go times 5,000. Gives me that number. Does that make sense, Dominic? Where did the 7 come from? The 7 is the time, how many times it's going to double, how many times it's going to, not double, but let me think here. The compounding period, right? So it's 7 days, and it grows by a rate of 25% per day. So we're going to do 25% 7 times. Okay? Good. All right. Let's do another one here. I'm going to make up one. I'll let you guys try to answer. Let's say we have growth, right? What doubles? Let's do a COVID question. Okay. This one's going to be a little different, but let's try to fill in the components of it. So we have A, we have R, and we have T. And we have like number of people infected. Let's go like, let's leave it like that. Oops, R plus 1 plus R. I did that backwards. Okay, let's start with the simple one. What's our A value for this? Actually, I'm going to change our A value. I'm going to change something in here. Let's start with 1 person. Good, so our A value is going to be 1. Okay. Now, infects 3 people, right? Well, let's do T value. Let's do T value first. Who thinks they know what the t-value is? If they infect 3 people every 2 days and 20 days exist, how many cycles do we have there? Not 20, every 2 days. Good, it's going to be 10. Okay, that's fine. That's why I threw this one in. Now, if it infects 3 people, that's just going to be like a rate of whenever you have these ones, if it doubles or triples, right? Like if I say it doubles, your R is going to equal 2. If I say it triples, your R equals 3. Okay? Because if it doubles, that's like 100% gain, right? Which would be like 100% plus 1. You divide this by 100, you get 1 plus 1. So whenever you see like a double, or this case here, we have a triple, this is going to make that one 3. Does that make sense, everyone? If it doubles, it's essentially 2. The R's would be 2. If it triples, it'd be 3. So let's figure out if you had one person, right? If we had one person with COVID, and they infected 3 people every 2 days, right? And this is actually how COVID works. What would be, how many people would have COVID? And this is like if we had no mask, no anything like that, okay? Well, first of all, how many people understand how we got to this equation? Do we have a yes, no, maybe so? Yes, I understand how we got here. No, I have no clue. Okay. Got it. Good. Good. So who can tell me the number here? Who can tell me my answer? Plug it into your calculator and see if you can get the answer. We're going to do, Andreas, we're going to do some decay soon, which is the exact same thing. Okay. This is like if COVID had, if you didn't wear masks or do anything like that, this is actually the replication of COVID within the community. So if you had one person show up with COVID, no one wore a mask, and we did everything as we usually did, this would be the transmission. So how many people, after 20 days of just one person having COVID, would we have infected with COVID? Who's got the answer for me? Or are you guys all waiting for me? The answer is 1,048,556. $576. Who else got that answer? Did anyone else get that answer and was just afraid to say it because it seemed ridiculous? Did anyone else get that answer? Okay. So I saw Dominic say how. Okay, so let's do a little thought experiment here, Dominic. Okay, so Dominic, you have COVID. You infect 3 people, right? Right. 1, 2, 3. Okay, so after 2 days, now is, I'm going to add you again in here because since you still have COVID, there's 4 people who have COVID, correct? Then after 2 more days, so on first week we had 1 person, second one we had 4 people. On this one, we're going to have, what's that, 12 people? correct? For time, right? And then this one here, we have 12 people. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then each of these have 3. That's 36 people, right? You're just going to keep multiplying this by 3, by 3. Yep, each person is going to affect 3 people each day. I feel bad because when we were in class last semester, we did an experiment of, think about a piece of paper, okay? If you folded that paper in half, right, you'd have like 2 layers of paper. And we did a thought experiment of how many times, hopefully Gabe, but I don't know. But we did this cool thought experiment, which I'll show you after, of how many times could you fold paper in half? Imagine you have the biggest paper ever. How many times would it take folding it in half to get to the moon? I might give that as a bonus question later. Okay? But we did that as like instead of teaching it this way, I taught it that way, where we kind of played with the numbers. And Mark and, geez, who was she? Mark and someone figured out the number. It's actually not that many when you think about it. Okay. So let's go to decay now. We've done growth, right? But we want to do decay now. So decay, here's the equation for decay. So write that into your notes to self. You go right here. And I would always write do an example underneath as well. You don't have to do it right now, but when we go through the examples. Where's my decay formula? There's your decay formula. So it's the exact same thing, but instead of a plus here, it's a minus. Okay. Gabe, let me show, remind me once I'm done teaching this lesson to go over the school thing with you. I saw a neat thing on Twitter this morning. So tell me when you're done writing this equation down, your decay formula. And then try, once you've done that, try to figure out your decay rate. So what's going to be inside the bracket, right? If my rate is 6.5%, what's going to be my last number inside this bracket? What's going to be this number? Okay. I'll wait till Andreas is done before I go forward here. So if you've already written down that formula, see if you can find that number there that's going to be in there. And it's working the same way we did before. So Andreas, you tell me when you're done writing this down. Tessa, should I put all this pressure on Andreas? Yes, I should put the pressure on him. Go ahead, Andreas.
I'm done.
You're done? Perfect.
Yeah.
All right. So in this case here, if I go over to this part here, I want to change that 6.5% into a number. So 6.5 divided by 100 equals 0.065, just like it was before. And we plug that into here, which is our R value, 0.065 And this time it's going to be 1 minus 0.065. So my number in there is going to be 0.935. Okay. How do we feel about that? Thumbs up? All right. Let's go down here and do a question about loss here. So I'm going to write down our numbers here. So after being filled, a basketball loses 3.2% of its air every day. The initial volume is 840 cubic centimeters. Okay, so let's figure out what numbers we know so far. So our A is our initial, so that's going to be 840. Our R is 3.2%. 3.2%, which is equal to 0.032, because we divide by 100 right here. And we don't know our T value. We're going to get into it down here. So our original equation would be, let's say, volume, I'll go volume T. 840, bracket 1 minus 0.032 to level T, which would be 840, 0.968. How do we feel about this right now? Does everyone understand how I got to this spot right now where I have 840? Good. Now I'm going to write down our formula down here again. What's my T value going to be here? It loses 3.2% of air every day. What's my value of T going to be? Good job, Kovats. It's going to be 4. So we're asking, what's the volume after 4 days? And I want you guys to use your calculator and find me the answer, okay? Let's make, who do we want to give us the answer, Gabe or Dominic? Which one? Who do we have votes for? Dominic? Okay. No, Dominic got first vote. So everyone else plug it in their calculator, have their answer on their calculator, and I'm waiting for Dominic. And Dominic, if you need help plugging in your calculator, just tell me. I can help you out with this here.
Yeah, how do I plug it into my calculator again?
Okay, so we're going to start with the bracket part first.
Okay.
So 0.968, 0.968. Okay, you got that so far, Dominic?
Yes.
And then we need to go to the power of 4. So we're going to hit the y to the x value here, y to the x.
I don't have that on my calculator.
Is it you're using your iPhone?
Yeah. Like it's that same thing, but I have like x to 2, x to 3, and then I have x to y.
Yeah, same difference.
Oh,
same
okay.
button. Yeah. So hit that button and press 4, because that's our exponent.
Okay.
And press equals. Did you get 0.878?
I did.
Then times that by 840.
737.53.
Let's round up to 738.
Okay. Awesome.
So how many people were able to give me a yes or a no in chat if you're able to get that answer? Thanks, Dominic. So give me a yes or a no in chat if you're able to get that answer. Yes, yes, yes. Good. Sometimes the hardest part of math for you guys will be like using your calculator correctly. All right, here's a different question. So a new car costs $25,000. It loses a percentage of its value every year. We call this depreciation. The model that describes the value of the car in terms of time is given with this here. What is the depreciation rate for this car? How much does it decrease per year? Yeah, Yosan, these are on OneNote. I'll show you the filled out. If you go to week 2, Monday has the filled out copy, right? And then what we're going through is in the class notes section. So you can always go back to what I wrote down. Who thinks they know what the depreciation rate for this car is? Remember that, I'm going to expand this a little bit. It would look like this, right? 1 minus blank, the t. The answer for this question here is 0.7. So what number is going to go right in there? So what number is going to go in here? If we want our answer to be 0.7, what number is going in that box? Not 0.6. Good guess, though. 1 minus what equals 0.7? Good. So 1 minus 0.3 equals 0.7. That's no problem, Yosan. 1 minus 0.3. So if that number is 0.3, what's the depreciation rate? So we're going from a decimal place to a percentage. We're going to times it by 100. So that depreciation rate is 30% per year. Oh, it's in the, I scanned it. Does that make sense, everybody? So, well, think about it like this, Dominic. If we have 1 minus something equals 0.7, we could put a value in there. Let's put x in there, right? So we could isolate the x, we can move the x over here. 1 equals 0.7 plus x, move that over there. 1 minus 0.7 equals x. 0.3 equals x. Oh, for this part here? Well, we're going from a number to a percentage. And before, when we went from percentage to a number, we always divided by 100, correct? Or if we had like 40%, right? When we're going from a number to a percentage, we times by 100. Okay? So here, I want you guys to do this question for me. So the value equals 25,000 times 0.7. Now, what's my t value going to be here? It goes down 30% per year. If I want to know the car's value in 3 years, what's my t value going to be here? Can anyone tell me that? Perfect. 3. Okay, Dominic, you get to tell me who I have to wait for the answer on. Who's going to provide me with the answer, Dominic? Okay, I'll wait for Gabe.
Come on, Gabe, man.
Well, if you need help plugging in your calculator, I can help you, Gabe. Everyone else should be
simple. I just don't have a calculator, so just give me a minute to go online and find one.
Do you have your phone, or are you watching this on your phone?
I have my phone, but I'm not confident with the iPhone one, man. That one sucks.
I know, but okay, we'll wait for someone. Who else is there? I'll find you. What kind of computer do you have, Gabe?
I got a MacBook.
Okay. I need to find a nice Mac calculator for you guys. Okay. Who else? Who wants to give me the answer here? Who figured out the answer for me? Okay, what is it, Farley?
The answer should be 8,575.
Do we have anyone that agrees with him? Yes or no? Good.
Nice.
8,575. All right, here's a question to mess with you. 18 months. What's my t value for 18 months? Who can tell me my t value for 18 months? Now, the key here is our t. Very good, Gabe. Our t value is in years. Okay? So when we have a different measurement, we need to change it over to years. Right? So how many months are in a year? 12. So we do 18 divided by 12, which equals 1.5. Gabe, who should we wait on then for who's going to give me the answer? Who's the person I should wait on for the answer here, Gabe?
Let's get Tessa going.
Tessa? I got mad confidence in Tessa.
All right, then let's do Ben.
No, Tessa, you pick Tessa. Tessa, whenever you're ready, or if you need help plugging in a calculator, just tell me. $14.68, $14.64. Let me see here. Watch your decimal places there, Tessa. 0.7. Good. So 14,462. Somewhere in there. Perfect. Oh, I see what you did. Okay. On a whole, how does everyone feel about this out of 5? 1 being I have no clue, 5 being I'm a master. Good, really good. Good. We're above 2, which is good.
The only part that I am like troubling with is like the calculator stuff, but like it's just because I don't own a calculator, so I haven't got to try.
Yeah.